Hello, welcome to part 2 of the electrolysis. Let's get straight into it. So we've got another example here, the electrolysis of lead bromide. Now lead bromide, the chemical formula is PbBr2. Go and watch a few of my ionic compounds screencasts to figure out how to name formulas or name compounds. Okay, so what we need for electrolysis, we need a battery, we need some connecting wires, and we need some electrodes. So I've drawn this for us over here. Okay, so we've got our electrodes. Remember, these electrodes are generally made of carbon, but they can be made out of platinum as well. And this is because I've spelled this incorrectly, but it doesn't matter, guys. They are made of these two elements because they are very unreactive, and they're not going to cause anything to happen. Okay, what I've included over here is a light bulb, and this is important because when we have a light bulb, we can actually see that electrons are flowing. So right now, this light bulb would be off. Okay, it would be off. It wouldn't be shining at all. Now, when we do end up putting these electrodes into our solution of lead bromide, remember it needs to be molten or it needs to be aqueous. In this case, it's going to be molten. And remember, these electrons are going to be pulled out. So they're going to be pulled out here and they're going to be pushed out here. Electrons are going to be moving this way. And then it's going to be moving through our compound and back up into the electrode. And then effectively what we've got here is a nice circuit. And if electrons are flowing around, we should see our light bulb light up nicely. So let's just get rid of all the stuff that we've written, and I can actually just take an eraser, so we'll be a lot faster. Okay, cool. So now let's take our apparatus. Sorry, I'm just going to be a bit of a perfectionist here. Let's take this apparatus and let's stick it into our sort of what can we call this, like a crucible or evaporating dish or something like that. So we stick it in. Boom. Beautiful. Now what's inside here is our molten lead bromide, and it's important that it's molten because when it becomes molten, it dissociates into these ions. Now we know Pb is going to be Pb2 plus. This is from our or lead, that is, it's going to, from our question. So there's going to be a whole bunch of Pb2 plus ions floating around in this dish, and there's also going to be a whole bunch of bromine ions, these Br minuses. Okay, now a few things to remember. I'm only going to draw 4, but there are thousands and thousands of these ions in this lead bride, molten lead bromide. Okay, beautiful. Now remember, we've got to write down a few things that are going to help us. Panic. We're going to write. No, don't panic. We're going to write down an ox. We're going to write down red cat. Okay, what do these things mean? Positive is the anode. So this electrode is linked up to the positive terminal, so we can write here anode. All right, and you must write this. On this side, negative is cathode, so we write cathode here. Okay, excellent. I am now finished with panic. I don't need this anymore. Beautiful. Now, an ox, remember, oxidation occurs at the anode. Oxidation is not a term we understand yet, but we're just going to write it down for now. Red cat happens at the cathode, so we write reduction. Okay, beautiful. Lovely, lovely, lovely. Now, we need to understand one concept, because this because this electrode is linked up to the positive terminal, you've got to sort of imagine that this whole side over here is positively charged, and this whole side over here is negatively charged, like this. And it's because of this concept that these ions are going to be attracted. So where's the Pb going to go, do you think? The Pb is going to be attracted to the negative charged electrode. So Pb is going to go over here, and Br minus is going to go over here. Now what's going to actually happen when those ions are attracted to these electrodes? Well, this is what's going to happen, because we need to remember one other concept that I taught you in the previous video, and that concept is that at the positive terminal we are going to have electrons being pulled out. So electrons are going to be moving this way. Electrons are being pulled this way, and they're actually going to be pulled from the bromine atom itself, or from the bromine ion itself. Okay, and then electrons on this side are going to be pushed. Electrons are going to be pushed, and these electrons, if I just drew a quick electron over here, let's just make sure this is nice and small. So if electrons are moving, so here come my electron, watch these electrons, they're going to move down the wire, they're going to move, and they're going to actually join up into this ion. So we're going to have one that goes in there, and in fact, because it's a +2 charge, we are going to get a second electron that is going to move in here. So these two electrons, let's get a black pen, these two electrons, electron and electron, they are going to be moving into this ion. Okay, so what's happening with this bromine, we're going to take one electron and it's going to be taken away from that bromine, and this electron is then going to be able to move up this electrode. And now we have this sort of flow of electrons. So at this point, what would you say is would be happening with the light bulb? The light bulb would be turned on, right? Because we've got this flow, this beautiful flow of electrons, which effectively is electricity. Okay, so let's neaten some things up here. What we've got here, let's do some reactions. So what happens over here? We've got a Br minus, that's this atom over here, and it is losing an electron. Okay, so it's losing an electron, so I can say it's going to turn into, what's it going to turn into? Well, bromine happens to be one of our diatomic molecules. So effectively what's going to happen here, we're going to turn this into Br2, and we're going to lose an electron. Okay, now this doesn't really make sense, because in the previous video I said that we have two bromine ions that join up, so we can actually have a second one join up here, and this would make a lot more sense. So we can have two bromine ions, which forms bromine gas, and we're actually going to lose a total of 2 electrons. So this is your official half reaction over here. Okay, these are called half reactions. You can be asked to draw a half reaction or to write a half reaction in your exams. And this is an oxidation reaction. I'm going to explain that later. This is happening at the cathode. At the anode. This is the anode over here. Okay, so what's happening on this side? This side here, we've got Pb2+, and Pb2+ is gaining 2 electrons. Okay, it's getting these 2 electrons, and this time it's going to turn into Pb. It's going to turn into actual lead. Now remember, bromine is a gas. Pb is a solid. So what visually, when you do this, I'm just going to remove a whole bunch of stuff here. When you visually do this, like in real life, what's going to actually start forming is, I wonder if I can do this. Yeah, I can. What's eventually going to start forming is bromine gas. Is going to start forming, like a gas is going to start appearing, and it's got this brownish color. It's going to start appearing on this side of the electrode, on the positively charged side. And what these colorful sort of dots are representing is one atom of bromine gas over here. What's going to be happening on the other side is we are going to start forming solid lead. So you're going to start seeing like dots and dots of lead, and of course, because lead is quite heavy as a solid form, it's going to start pooling at the bottom over here. You're going to have a whole bunch of lead forming on this side. So this is another example of electrolysis of lead bromide, like I've explained with sodium chloride earlier. So let's just write down those two half reactions quickly. So we've got 2Br minus becomes Br2 plus 2 electrons. Now there is actually a better way to write this, because we need to show what state these atoms are in. So I'm going to start doing this from now on. Br minus, I can put in brackets the state. It's in an aqueous state, otherwise known as molten. It means it's in ion form. Okay, not ion as in like Fe, but like ion, like an ion or cation. Okay, and this is going to form bromine 2 or Br2, which is a gas plus 2 electrons. This is one of the half reactions. Okay, the other half reaction, number 2, is on the right hand side here. We have Pb2 plus. Again, if you see a charge, it's always going to be aqueous, and it's going to gain 2 electrons to form Pb, and we said that Pb is going to be a solid. So you put these into, you put these states in, you don't have to worry about the electrons. Okay, let's just get rid of this diagram quickly, if it allows me. Okay, so now what I can do is I can summarize these half reactions by combining them together. Everything on the left hand side to everything on the right hand side. Let's do this. 2Br minus, that's this one over here on the left. What else is on the left? Plus 2, not 2, plus Pb2 plus 2 electrons is going to give me Br2 plus, what else is on here? The 2 electrons, so I'm actually just taking it from here, plus Pb, we can actually put solid. Let's put in the states here, aqueous and gas. Now the electrons of course are going to cancel, and then we've got everything left over. So we've got 2Br minus plus Pb2 plus. It's going to form Br2, which is a gas, plus Pb solid. So this is your final equation over here. Whoopsie. Excellent. I hope it's been super helpful, guys. And if you got any questions, please do let me know.